Please take roll.
Chair Hoadley,
Here.
Representatives Bonak,
Here.
Outman, Harris,
Here.
Bagol,
Here.
DeBoyer,
Here.
St. Germain,
Here.
Grant, Rixey,
Here.
Tate,
Here.
Kofia. Mr. Chair, you have 8 members present. You do have a quorum.
Thank you. Representative DeBoyer makes a motion to approve our previous meeting minutes from the 26th. Seeing no objections, the minutes are approved by unanimous consent. Next, we are going to hear from Automation Alley, a nonprofit technology business association. Specifically, I'm excited to hear about Project Diamond. Mr. Tom Kelly, Mr. Pavan, I'm gonna try not to bush it. Go. I'll let you pronounce it. Mazumdar. Welcome, and please come up and begin when ready.
Thank you, Chair Hoadley, and thank you to the members of the committee. We also have special guests, if okay with you. We have 2 manufacturers that have joined us, and they'll come up at the conclusion of my remarks, if that's okay.
Yeah, perfect. I'll allow you to run your presentation how you want, bring people in and out as you'd like, and we'll hit with questions and answers.
Thank you.
When you get that slot.
I have about 5 minutes of prepared remarks to make sure everybody sets the stage of what Project Diamond is, why we're doing it. We'll go from there. Is that okay?
Let's roll.
All right. Chair Hoadley, Vice Chair Bonak, Vice Chair Grant, who's not with us, and members of the Economic Competitiveness Committee, thank you for the opportunity to testify. I'm Tom Kelly, as I was introduced, the CEO of Automation Alley, Michigan's Digital Transformation Center. We have nearly 4,000 manufacturing members, 1/3 of all manufacturers in the state of Michigan. So that's important. We have members in every county in the state and in all your counties, about 1/3 of all manufacturers in the state. Our mission is to help manufacturers adopt advanced technologies like additive manufacturing, artificial intelligence, and robotics so they can compete and win in a digital-first economy. We do this through hands-on training, technical assistance, peer networks, and public-private partnerships that turn emerging tech into practical factory floor results. Project Diamond is the most powerful example of that mission in action. Born in 2020 at the height of the pandemic, it began as a resilient, distributed network of 3D printers placed with small manufacturers to produce critical parts on demand. First PPE, you remember the PPE crisis, and now commercial components and prototypes. In fact, Diamond stands for Distributed, Independent, Agile Manufacturing on Demand. Working with Oakland and Macomb counties, Phase 1 deployed hardware to roughly 300 small and medium-sized manufacturers and connected these machines into a secure, centrally orchestrated network. So a single digital file can become hundreds of identical parts produced across the region simultaneously. Since then, the network has matured from emergency response into an infrastructure and innovation that small manufacturers use daily. As of August 12, 2025, just a week ago, Project Diamond has completed 51,153 prints, demonstrating real throughput, real customers, and real value for our smallest Michigan suppliers. We believe it is now the nation's largest distributed 3D printing network with training and a digital marketplace layered on top so companies can commercialize designs, speed iteration, and keep production local, the most important facet. Our success rests on a strong regional partnership. Oakland County's early leadership, along with Macomb, proved the model and funded expansion. Wayne County has now joined and will add additional small manufacturers to the network. Together, we are lowering costs for small manufacturers, shortening lead times, and building resilience into Michigan's supply chains. The 3 county executives and the governor have all publicly endorsed taking Project Diamond statewide, a testament to both the momentum achieved and the demand we are seeing from manufacturers beyond Southeast Michigan. Why is this so urgent? Because small manufacturers, the backbone of our industrial economy, are being whipsawed by the pace of technological change. They face thin margins, talent shortages on the shop floor, cyber and data integration challenges, and capital constraints that make it risky to bet on the next big thing. Even firms that want to modernize get stuck in what we call pilot purgatory. They test, but they don't know how to scale, and so it stops there. Project Diamond eliminates these barriers by 1, providing access to production-grade 3D printers, 2, providing hands-on training and a community of practice, and 3, plugging companies into a working network so digital transformation is immediate and compounding. That's why we're here today, to make clear the need to expand Project Diamond statewide. We believe Michigan's manufacturing competitiveness can be greatly increased by extending the Project Diamond network to an additional 1,000 manufacturers in every corner of the state, prioritizing rural and underserved communities. We need to add 3D printers, materials, and software seats where demand is strongest, and stand up regional training hubs with our community college partners all around the state. Expanding the secure marketplace so companies can share digital recipes, monetize their intellectual property, and fulfill on-demand orders across the entire network. And we need to track hard metrics like jobs completed, lead time reductions, supplier wins, and new products launched. We are investing in Michigan's competitive capacity, our ability to out-innovate, out-learn, and out-deliver, especially against China. The network has already shown it can mobilize quickly in a crisis, help small firms win new business, and keep production here at home. It has county-level backing, support from our governor, and a growing body of measurable results. The next step is to make this Michigan statewide platform for distributed digital manufacturing. So in closing, members of the committee, Michigan has always led when we built the infrastructure of the future. After all, we literally created the second industrial revolution through Henry Ford and the assembly line. In 2025, the infrastructure of the fourth industrial revolution is digital and distributed. Project Diamond gives every Michigan manufacturer, from Marquette to Monroe, the tools, training, and network effects to thrive. With your support, we can move aggressively from a regional success to an unparalleled statewide advantage and ensure Michigan remains the best place in the world to make things.
Great, thank you. Probably be best to continue on with some of the, the meat and potatoes here before we open up to questions. So go ahead and continue on with whatever format you'd like.
Great. So if it pleases the chair, I'd like to bring up George Caravias from GeoFabrica, one of our manufacturers in Project Diamond, and I'd also like to bring up Aravind Janalagada from, I hope I got that right, that's a mouthful, from Synergy Additive and Synergy Group, and also on our Project Diamond network. And I'd also like to reintroduce Pavan Mazumdar, who may also chime in, but if it's okay, I'd like to start with you, George, and maybe give a little background on how the crux of Project Diamond, because we do want to leave time for questions too.
Thank you, Tom. And thank you, George. Push the red button. Is that okay? Is that okay? Thank you, Mr. Chairman, and thank you, members of the committee. It's a real honor to be with you today and to talk about this, what I believe is a very important program. I'm George Caravias. I'm the CEO of GeoFabrica. We are a company that makes manufacturing systems. The way I like to explain the company is that our customers come to us and they say, hey, I've got this design for a widget. Will you create a process or a machine or a combination of machines and processes so I can produce it at all, better, faster, cheaper, faster than the Chinese, and increasingly we've been getting requests from the Department of Defense for machines that will operate on ships or on the battlefield or at a forward operating base. So what we do is essentially provide competitive capabilities to other manufacturers and make things. This is an example of a part. Usually we work from a design that an engineer has that doesn't know very much about modern manufacturing techniques, may not know at all about additive manufacturing and digital manufacturing. And what we can do is help them get an especially competitive product. And it's been a big boon to have the Project Diamond technology as part of that, because this is a carbon fiber printed part. Otherwise, you'd have to make an injection molded component that would require molds that are very expensive, typically $50,000 or $100,000 per mold. These probably would have taken 2 or 3 molds, and it would have taken weeks or months to produce this item. In fact, what we did, and this is just an item in which pellets are brought in, they're kind of aggregated and they go down out to an extruder. We were able to go through multiple designs in parallel with the engineers and show them prototypes of the machine while they were developing the product. And all again produced as a very, very strong part that can take a lot of wear on the Project Diamond equipment. This is probably the least sexy part I've got, right? But I think it's maybe the most interesting story. One of our customers makes doors for military transport vehicles, and they had an urgent need to get 400 doors shipped with, and they needed 830 of these little handles. That is just a lock. This part was originally designed as a metal part, and it was overmolded with kind of a plastic, almost a rubbery type material. So it was a 2-step process where they had to get the metal part first, and there was a manufacturing process for that. And then they had to dip the metal, they had to make sure that it was all trimmed off, and then they then it was ready to use. What we did was we redesigned this part for carbon fiber production on one of the Project Diamond printers. Now, what's unique about it is that we oriented the carbon fiber so that it had the same strength as a metal part would. And they do extensive testing, as you would expect with the Department of Defense. But because we made it as one plastic part with the necessary exterior coating, we took the price down to about half of what it was, a little bit less than half of what it was originally. The unique thing, though, is that producing these handles on our the few 3 printers that we had in-house would have taken us about 3 months. By distributing these parts over the Project Diamond network, we were able to tap the resources of the Project Diamond community, and we were able to give these parts in weeks, deliver them to our customer in weeks. So I think that's really unique, because what it did was it gave this manufacturer, even though it's probably one of the least expensive parts on these military doors, none of those doors would have shipped without this handle. And that type of competitiveness and that type of speed, just would not be possible without the military technology.
And George, I'd like to jump in super quick for the chair and the committee. We also have another great example of using the network. The network was designed for PPE, for emergency use, and then it moved into commercial because that's how we qualified for the funding. We never printed PPE because the crisis passed by the time we got the program stood up, except the Ukraine and Russian war broke out, and Ukraine put out a request for the world. We need tourniquets fast. We're going to war. We need 100,000 tourniquets. We asked Oakland and Macomb County if we could activate the network. They said yes. We printed 10,000 tourniquet parts in 7 days, and we shipped to Ukraine. That is exactly the surge capacity that we're talking about. And it's not that the military has all these manufacturers that they're paying to stay alive. It's like these manufacturers are living their lives. And the minute we pushed the button and said, we got an emergency, they started making tourniquet clips. This is what we're talking about. This is why we need to push this out to all corners of Michigan, because the competitive advantage for us is so huge. And there's nobody in the states that are doing this yet. So that's why we're asking for your support. We got to get it out. So, again, with your permission, I'd like to turn it over to Arvin, who's got a story as well.
Members of this committee and the chair, thank you so much for this opportunity. My name is Arvind Janlagada. Name is pretty long, so you can call me AJ. I'm the CTO and co-founder at Synergy Additive Manufacturing, which is a part of larger Synergy group. Prototype stamping and mold technologies is also what we do. Together with the three companies, we provide all metalworking solutions, from stamping to CNC machining to additive manufacturing, laser hardening, pretty much you name it, we got you covered. First, I would like to thank lawmakers of the state for supporting small businesses like ours. I'm truly, truly thankful. My own journey began 7 years ago when my partner and I saw an opportunity here to use high-power lasers in manufacturing. I left my well-paying job, bought a robot out of eBay, and borrowed a laser from my friend. It started with a one-person company. Now we're 7 people spread across 2 locations, one in Clinton Township and one in Grand Rapids. What we do is very interesting. We do a technology called laser hardening. This process lowers die making cost and strengthens Michigan's competitiveness, meaning the cost of making die substantially reduced because laser hardening avoids a lot of secondary operations. We are the first company in the United States to introduce these technologies to OEMs. Today, we are trusted suppliers for Stellantis, Ford, Tesla, and other OEMs. We also 3D print molds. We have come up with new innovative techniques where we can join multiple pieces of molds with laser welding and build larger molds which are substantially competitive.
And I don't want it lost, those are 3D printed metal
3D
parts
printed
that he
metal
showed.
parts.
That's not dyed or molded, that's 3D printed.
There's a sample with 3D printed metal parts, and we're able to join these metal parts and make a larger mold, which is substantially more expensive. So now we can have a distributed network. We can send these tiny pieces all across and then get them back, weld them, and make a bigger mold and make them way competitive compared to overseas. We have in the process, we have invested substantially in research. Over the last few years, we've been working with Department of Energy. We have worked on advanced additive manufacturing processes that work on corrosion and wear resistance. We've most recently received a small business innovation grant from U.S. Naval Air Systems Command. This grant improves current coatings on helicopter components. That is expected to improve the readiness of our fleet and by reducing the maintenance costs and make our fleet more stronger. Michigan's support all through this process has been vital for us. Programs from MEDC, Automation Alley, and Velocity has given us talent, training, and good part of business acumen. I'm a CTO, I'm a technical guy, right? Running a business leads a lot more. So these programs massively helped us. The STEM Ahead program, which we use every semester, helped us with interns. We typically hire 1 to 2 interns. The GEM grant funded our risk strategy as how to go to the markets. And Going Pro Talent Fund trained our employees from a CNC perspective to robots. So we use robots everywhere. So GEM grant really helped us to train them. And Project Diamond gave us one of the best Christmas gifts ever, a world-class 3D printer. At first, we saw it as like a free tool, right? But once we began experimenting, the real value became very clear. Having this tool reduced our time from an idea to production. For example, we are having issues when we're 3D printing with metal. We use powder, and there's too much gas, and we're losing efficiency. So we asked our intern, hey, what can we do? And she came up with this cyclone chamber. We call it Erica's cyclone powder separator. She came up with an innovative idea where this device reduces the powder flow and take out excessive pressure. It reduces kinetic energy of the particles. Essentially, we are using this in every 3D printer we are selling, but 3rd or 4th version, which is much more compact. Another student came up with the idea of iris when I asked him how to calibrate this powder. So he took out the conventional process and make some cool things like that. It's not just cool, but it really helps us to move our needle towards becoming more competitive, spending our time in research.
And Aravind, I want to stop you for just a second and make a very important point to the committee. So, because you said something, you said, we got this free printer, and we thought, we'll take it, it's from the government, we'll take it, it's free. That's by design. I know it turns economic development, everybody says, well, isn't this corporate welfare? No, it's not, because they will take the tool even if they don't know how to use it, but they will never buy it because they only invest. Manufacturers make economic decisions, right? And they say, I'm not going to buy that printer till I learn how to use it. Meanwhile, the world is passing them by. And that's why we convinced Oakland County to put $25 million into this project, 10 in the first phase. They came back for 15 million more because they said, we need every company in Oakland to understand that this is not optional. And so we change culture by giving them such a tasty morsel that they have to take it. And then they're like, well, damn, I better learn how to use it. Ha, gotcha. That's exactly what we want to have happen. And it's happened to you.
Absolutely.
We have many stories of manufacturers like, yeah, I was in the box for the first 6 months, government free. And then they kind of take it out of the box. And then the next thing you know, they got an engineer kind of piddling with it. And next thing you know, they're in the business of making digital additive components. And that's what's going to beat China, right? So that is the message, Chair Holdley.
Well, what I would add here is our request from manufacturer's point of view. Number one, obviously, if this has done so much good to us, it can do good to so many other people around, so many manufacturers. More importantly, we wish not just plastic. There is more metal 3D printers available in the market or available in the network that we can tap into. And small matching grants. For example, we have some ideas, right? Not just 3D printing. We still need a little bit of resources. Need not be much for us to take this idea, buy other parts, test it out. Last but not the least, we would love to have talent. For example, the STEM program gave us interns for 50% cost, which is awesome. More programs like this put together will complete the ecosystem and really help us thrive. Yeah. Okay. Bottom line again, sincere thanks and gratitude to all the team. And with your support, we will go places. Thank you.
Thank you. Thank you, Robert. Thank you, Chair.
Yeah, great. Thank you. I got to say, before we open up questions, make a few comments. I'm intrigued. One, I'm intrigued about 3D printing metal, right? That come from nylon and soft porous type materials, but that is completely amazing. I come from a light manufacturing background myself and military, so I know what it's like to have to use, supplies built by the lowest bidder. That was a joke. But also in manufacturing, I was in the archery industry, right? So that's kind of a niche market. So a lot of my parts needs were small. So when I would be developing, particularly in the accessory market, I've got a specific example of a bow quiver, right? That holds the arrows and it attaches to the bow. And I was designing a 2-piece, which, by the way, full circle is I bought a CNC when that technology came available, and I self-taught myself that. And my employees would joke about me wearing out the concrete from my office to the CNC as everything was going wrong, right? But where I was going with that is I had a specific rubber washer, if you will, like a horseshoe thing with a hole in it, very simple. And it was in between the quiver and the bow so it wouldn't mar up an expensive piece of archery equipment. It took me months just to get those little rubber pieces that I was only going to need maybe a couple thousand pieces of, and I had to buy a $15,000 injection mold. It wasn't right the first parts run, so then I had to make modifications to that mold. So it actually took months just to get that little part to package my accessory and get it to market. So I'm very intrigued in what you do. So from there, I'm going to open it up to questions. We've got Representative DeBoyer.
Great, thank you, Chair. Thank you guys for being here. I do represent parts of Macomb County, so I really appreciate everything you guys do, and I love that place. I'm just going to shift gears really quick. I have an appointment, but I'm going to bring something up. If you're comfortable enough to talk about this with the committee, I would love, because it's an issue that I'm working on. It's the CMMC certification. I don't know how familiar you guys are with that. I imagine you are probably very familiar with your industry. But the issue that exists with that certification, with some of the smaller mom and pops, the cost to do it, the hoops they have to jump through. And I would imagine there might be some members here that really don't know anything about that. But I'm pressing that issue because of, obviously, the manufacturing ability in Macomb County, the defense sector, the value of that defense sector. Michigan has all of the tools to be the absolute leader in defense manufacturing, and that CMMC certification, I think, is creating a little bit of a hurdle for some organizations, some structures, some corporations. And my goal is to get the state to help with that, to maintain it. I actually have to leave. Would you guys, you don't even have to do it right now, but at some appropriate point, would you guys talk about this so these members have a really clear understanding of the importance of that and why help from the state of Michigan might be appropriate on that? Would you mind doing that if it's appropriate?
Yeah, I can spend maybe just two minutes as you're walking out the door. So CMMC is the DoD, the Department of Defense's cybersecurity initiative that can be very onerous because most smalls don't understand cybersecurity to begin with, and they're putting all these hurdles in place as you got to do this, got to do that. We have a lot of ideas at Automation Alley that we should talk about, which is you need to build a secure cloud that then the smalls can participate in so that the cloud itself is CMMC compliant. And it takes the cost and burden away from the small and pushes it into a common entity like an Automation Alley that's appropriate to manage it. And then the smalls pay a fee to be in that cloud. And that is the way to do it. So that's just our 2 cents, Rep. Boyer. Yeah. Just, you betcha. Happy to talk. I eat, we all live, eat, breathe this stuff. So.
Thank you. Representative Tate.
Thank you, Mr. Chair. Gentlemen, thank you all so much for making the time to trek up here to Lansing. And I have several questions, but I want to be respectful of my colleagues' time and your time because this is quite fascinating. And George, I'll say, I know you said that piece, that you created for military vehicles is not sexy. I would say, as serving our country, and Mr. Chair knows, and others on this panel, when you're out in the field, it becomes really sexy. Especially if it doesn't work. But my question I have, as you mentioned, Tom, you said too that there's no other state in the union that's kind of doing this and setting this network up. When you're looking at, if you could just unpack this a little bit more, the small firms that you are working with, is there certain criteria? I know they don't have to be skilled on that. Just I guess how would a firm, how small is it?
Yeah, sure.
Is it time dependent? Just kind of unpack that
I'm
for
going
us
to
a little
give
bit more.
Pavan some mic time. If that's okay with the chair.
Well, I run the program, so I should
Yeah,
be able
you
to
should
answer
know
this
about it,
question. So thank you, members of the committee. In terms of what the small companies have to be ready to do, this is such a significant platform shift in terms of what manufacturing used to be and where it's going that it may sound a little, contrived, but it's actually just have the attitude for learning. Because what this changes is, traditional manufacturing, and reportedly you said this, is so process dependent. We know how to do things. We know how to do what I call the INGs, machining, molding, casting, and these are disciplines that have been built over decades. 3D printing completely changes that on its head because all the process of how something is made is in the computer, and really what you have to contribute is your imagination and the 3D design. So in some ways, even traditional manufacturers are starting from scratch. And in fact, we also find that the more you know about traditional manufacturing, sometimes that becomes more of an impediment. And I can have maybe, even George talk about this. We've talked about this before. The more you know about process, the less sometimes you find 3D printing as interesting because you know how to do something differently. So to answer the question, it really is dependent on what it is that local community requires. So for example, in Oakland County has, a overrepresentation of sort of what we call computer capable jobs. So we were looking for people that have engineering capabilities, et cetera. Like those would be the qualifications to kind of boost that particular demand. In Macomb, it's aerospace and defense. In Wayne County, it might be something completely different. And so really it is up to what does that local community need? We've talked about, for example, in our agricultural communities, maybe it's focusing on parts that would be designed for that particular application. And it's really about the 3D ideas that you have and your willingness to learn. Because what we've talked about and touched about a little bit is we've built something called Project Diamond Academy, which is a 10-week course where you actually have to go in very, very little prerequisite knowledge to understand how to use 3D printing. And then we have something called the Digital Transformation Center, where you can actually put some of those in practice along with your printer. So it really is a blank page in terms of the qualifications of companies that want to come in.
Thank you. Yeah, great. Intrigued. I would think with what you're doing, you probably got a little bit of a finger on the pulse of what's going on in other states, right? And of course, our goal here is to make Michigan the go-to in a global market for manufacturing, and knowing that Michigan, you know, the sexy headlines come from GM, Ford, large manufacturing, but the reality is there's a lot more of those tier 2 suppliers in this state and other small niche type businesses, which is what I would even considered mine, even with global distribution. So how, unpack a little bit of where Michigan is, whether it's with regulations with other states, maybe other material supplies that you can't get here in the state, and with your processes there, are you prototyping for companies outside of the state?
So the way I would answer that, Chair Hoadley, is Michigan hasn't really had a competitive problem with Indiana and Ohio. I know that happens. I know that the situation crosses the border. Michigan's had a China problem and a Mexico problem, right? We can compete with Ohio and Indiana and California and anybody that does manufacturing all day long. We have great talent. And our premise when we did Project Diamond was the way we're going to economically win is we have to change how manufacturing is done. In fact, manufacturing will change. It will move to digital. We have to ride that wave and not resist it. And so within the state of Michigan, where we get frustrated is, you know, when you create 100-year systems that create great wealth, you are loath to change. Regardless if you see the future, you're like, no, I'm going to milk this as long as I can because I don't even know how to get over there. So that's why we created Project Diamond, was a step-off point that says, you don't have to be scared. We got you. Here's your printer, and here's PD Academy, and you don't need to know a dang thing about how to do additive, but we know you know how to make things, and that's the most important criteria. So we would say, with all due respect, it's a China and Mexico problem, not a other state problem. We think that there's plenty of room for America to win. You know, if we've lost 20% market share on the global stage in manufacturing and we go digital first, we'll get that market share back, and in spades. So that's that would be our stake in that.
Tom, is there a minute that I could just add to that, please?
It's up to the chair.
Mr. Chairman? Yeah. So these are covers from a charging station. Colleges now increasingly have to have charging stations that are certified because kids have, you know, charging stations that catch fire when they use them. So there's a company here in Rochester that is, I think, is probably going to become the national leader of these. These are just cover parts. These almost certainly would have gone to China if it were not for Project Diamond. These would have been injection molded. A lot of the tooling expertise, that's the expertise for making the molds, has gone to China. But what we were able to do was make these parts, actually have face-to-face meetings with the engineers at this company and deliver them 80 parts at a time, 100 parts at a time, so they can manage a just-in-time inventory and have these parts without having to take the tooling costs and the production to China. So it made, not only was it business for Geofabrica, but it also made this Michigan company considerably more competitive. The other thing I would add is that there are no prototypes here. Every one of these parts is an industrial part for a product. So we're way beyond the stage of making Darth Vader masks with 3D printers. What we're doing now is making parts that go in military vehicles and making parts that are used for safety purposes on college campuses.
I would say most of us are beyond that stage.
Yeah, absolutely. As I said earlier, you know, the prototyping process, you know, and that was just one example of one small part. I went through the same thing when I came to the quiver hood and the little rubber fingers that hold it. I mean, it sounds pretty frivolous, right? All these little details, but it took almost a year to get a product to market, and then to scale too, right? My business was smaller, so doing things on a smaller scale, and in injection molding, after paying all that money for the mold, then there was minimums to bring this little piece down under a quarter a piece, right? You start getting into the dollar cents of that. So then I'm overbuying all this to make sense of all the investment that I have in it. And then you're limited to changing that product in the future too, once you've got all that money invested into a set product. So that's one of the keys to 3D printing, is being able to change on the fly. So I'm very intrigued with this. But going back to the original question, are we bringing in businesses from outside the state? Or are you, you're not limiting to just doing parts for Michigan companies, right? That's just our network of who the manufacturers are in Michigan, correct? Just clarifying that.
That's a great question. And what I'll also jump into, when you mentioned your experience of having to produce something, overseas, there is a real risk of loss of intellectual property. Because what happens is, and we have an example on Project Diamond. He was getting some product made in China, and what he was finding is knockoffs of his product showing up online. And he brought his production in-house and is now producing them on a Project Diamond printer. So there's an example of that intellectual property. So as Tom mentioned in his remarks, one of the things we're building is what we're calling the secure marketplace. And the idea is that we would be able to produce and print anybody's design without them compromising their intellectual property. So if I have a product that I have designed and I have tested it on my own printer, I can then send that out on the network to any manufacturer on our network and have that produced, but that manufacturer does not get their hands on my design. They just get to print it and ship it to me. They don't get the geometry, they don't get the specifications or anything like that. All they're getting is the same thing that they would get had they just basically bought this off the shelf, which they can do anyway. So to your question, this marketplace will be open to anybody in the country to place parts on our manufacturing network. And all they have to do is put their smart product recipe, we call that the digital product recipe, on the network for print. So this is the infrastructure that we're building in phase 2, and we're continuing to develop that.
And can I add a point? So I mentioned in opening remarks that Project Diamond just last week surpassed the 50,000 print level. So we can see on the whole network what's happening, but we can't see where those parts are going. We don't know how many of those parts that small manufacturer took an order from a company in Texas, and they printed them and they shipped them off to Texas. That's exactly what we want. And we purposely set it up so that we don't want to be in the business. You guys run the business, and they're not going to share with us who their customer is. That's their lifeblood. So, but they can print the parts, they can ship them all over, and we don't have to see it.
Just kind of dig into the weeds a little bit here. So what are your restrictions? What roadblocks are your members facing, particularly in the state of Michigan? Is regulations, taxes, workforce, energy. I think that's a huge thing too, being in manufacturing, lasers and our emerging technologies and 3D printers. Energy, it takes a lot of electricity to run a manufacturer, and the manufacturing of tomorrow is going to see increases of needs from the grid, not less. So I just kind of unpack some of these maybe specifics, whether it's regulations, taxes, all the above. We want to be able to expand Michigan, right? So we need to know these little nuances that are holding us back.
I think we have two excellent resources. Arvin, you want to spend just a minute with that?
I would say taxes and talent. Obviously, as a small business, we like to minimize our tax burden, and talent has been still a major shortcoming. People with right work ethic and being able to work flexible manufacturing hours, being able to make their hands dirty, right? I think that's what we need. We need to make manufacturing look sexy.
Great, thank you. Representative Bagol.
Thank you, Mr. Chair. We've all heard about the 3D printers. I've personally never seen one in operation. Is there a manufacturing place around Lansing that we'd be able to take a look at how it works? And my next question is, what are the limits to it? How big of an object? I see some smaller things here. is there a size limit on what can be printed?
So George, first, I guess I can handle this. So first, Project Diamond is funded by Oakland and Macomb County and soon to be Wayne County for their regions. So we have to bring you to Oakland County, but we'd love to take you, all of you, and we can set this up to have a tour of what we call our Digital Transformation Center. Because without getting into the weeds, but we have 500 manufacturers now on the network. We have assets at the Digital Transformation Center that are much more sophisticated, $1 million assets that all 500 smalls can use to do metal, to do high volume runs. It truly is a different way to think about manufacturing. And so we'd love to share with you.
And then to answer your question, it really is, there is no limit. There's a company called Relativity Space that's 3D printing rockets right now. And so it really is a completely different way of thinking about manufacturing. So the design for a tiny part like this, well, it's not too tiny, but a part like this, and the design for a rocket looks exactly the same on the computer. It's about how it gets manifested in the actual production that changes. And that's what's fascinating about 3D printing. There's actually talk of printing entire ship hulls with 3D printing technology. So there's really no limit. It truly is imagination.
Thank you. Yeah, so we talk about, right now, 3D printing, right, is today.
Yes.
And it's, moving beyond what was yesterday. At some point, maybe this is going to be yesterday. So, clearly you're staying on the cutting edge of technology, trying to keep your eyes on the horizon as to what's coming next. What technologies or sectors do you think is going to be the next transformation in Michigan? What do we have to have our eyes on?
So what we really need to have our eyes on is artificial intelligence superseding, or what I would say, integrating with manufacturing. We're already seeing that in software development. Software engineers are less and less coding by hand. They're basically using AI tools. They're telling the AI to write the code for them, and then they're overseeing the code. That is happening already in manufacturing. In fact, AJ's company is already using some elements of that. And so imagine a world in which the engineer doesn't go to a CAD software and start designing. They actually ask the AI to say, hey, I want a manifold that moves this much fluid at this rate with this viscosity, and the AI comes up with the design. And what's going to be interesting about this is that the design is not going to be made for traditional manufacturing. It's not going to be injection molded. It's not going to be casted. It's not going to be machined. It's going to be 3D printed, because that is the natural geometry that is going to come out of it. And we're at the beginnings of that. And this is why we need to have the network completely ready, because when that next phase comes in, it's almost like that. If you've watched Back to the Future, they're putting in the red log in the locomotive. That's what's going to happen to 3D printing. It is just going to shoot out, and we better be ready as an ecosystem to take that and really put that on the ground level. To us, AI is the next frontier, and it is going to impact every single field of manufacturing.
Yeah, very
if you
good.
think about 3D printing like the Star Trek replicator. What prevents it from being a replicator today is actually AI. So as AI gets more and more and more sophisticated, 3D printers will look more and more like replicators of anything at any time, and we need to be ready as a state.
Yeah, I chuckled a little bit when you were talking about that, because I talked about wearing out that path from my PC out to the CNC, right? It's the same thing. I'd go from CAD to CAM, develop the tool paths, go out. It doesn't work. I got to find out. Come back to CAD, and it's telling me, well, there's a problem with your drawing, right? And you could have a line that's intersected or a corner that's not crossed, and it won't create the tool path. So, looking at AI, that might have been something that would have saved me a couple dozen trips out to the middle of the production floor. But we've got a question from Representative Brixey.
Thank you, Mr. Chair, and thank you, gentlemen, for coming and telling us about some really, truly exciting and innovative work that's happening right here at home. I have, I think, two different questions for you. And the first one, our chair mentioned the need for power. And you were mentioning that they're 3D printing rockets. What about solar panels? Is there any opportunity for 3D printing in the solar panel production and something? Would that be an appropriate thing that could be done that way?
So first of all, in semiconductors, they use a technology called stereolithography, which is actually a form of 3D printing, right? So I think the issue there is that you still need very high capital equipment to actually create that at scale. However, putting those in practical applications requires a lot of ancillary product, and for sure, that would be something that could be made possible with 3D printing. George's example of that charger, that charger is actually, those particular products that he's showing, those were actually designed to make those chargers fit a very specific geometry. So there's definitely application. It's maybe not in the core panel itself, but in its application and making it cheaper and more efficient to put in any kind of an installation, absolutely.
Great. Oh, thanks for that information. Okay, the second question I had, as a former treasurer, I kind of have to connect some dots. So you mentioned that taxes and talent were two things that were impediments to your industry burgeoning and growing and being bigger. But you also talked about $15 million, I think, from Oakland County. Is that right?
Actually, Oakland
20
County has $25 million.
25
in the
million,
project,
okay.
and Macomb at 2 and Wayne at 5.
Okay. So that money was tax money that you received, right? That's some of the great things that
Federal dollars, correct.
that's something that's tax dollars being spent on really great things. So that's something that our tax dollars go to. And another thing that our tax dollars go to is universities and schools, K through 12, to provide trained people with talent. And so just want to make sure that we keep it all in perspective, that when we're providing you with matching grants or when you're receiving grants, those are coming from taxes. And so if there aren't any taxes, then there isn't the ability to do those types of things.
And if I may, Representative Brixey, so Representative Tisdale has put in a request for $20 million for Project Diamond, but that's to touch 1,000 manufacturers across the entire state. So I think we're all in agreement that it has to be the right investment at the right amount at the right time, right? And we are true examples of that. We, as a nonprofit, we live the world of economic development, and we have to invest the dollars we get from the state and the federal government very wisely. And we've chosen to invest them this way, and we think it's paying off mightily.
Great, thank you. Yeah, and what I really like, though, is the opportunity to invest in the smaller businesses through the state and not just the massive headlines of these economic development dollars going out to businesses that far too often overpromise and underdeliver. So it's nice to have programs where we can take less money, spread it further, and also get some of that development dollars into rural communities in northern Michigan too, where a lot of our tier 2 suppliers and smaller, even niche businesses are. So I think having a pivot in that direction is probably key when it comes to economic development dollars. So.
And Chair Hoadley, what's nice, I think, is that we didn't know where this was going to go when we started out. This was, CARES money. The federal government came in and just dumped cash on everybody. And Oakland County was very smart. I will give them credit. They said, Tom, we're going to push cash out to solve the crisis right now, but I want to hold some back. Can you propose a project that is strategic? So we're not just wasting the money. We actually have something that will carry on going forward. And we proposed Project Diamond because it qualified perfectly. It was to buy 3D printers to make PPE. But we knew that that crisis would end, but the printers would stay behind. And so we were able to validate, and that's what brought Macomb and Wayne to the table. And it's almost funny. Usually, you know, it goes the other way. The state starts driving something, and you have to get all the counties on board. The counties are already on board. In fact, we have about 150 manufacturers outstate that are already on a waiting list saying, hey, as soon as you get it, we're in. We want to be front of the line. And that's through word of mouth, because we say we have no program. If we were to turn on the spigot, we'd probably have 1,000 like that. So the demand is there. The desire to want to learn is there, and we have to help them. We have to help them get there.
Yeah, absolutely. So do you guys have a matrix or a way of measuring what that success is, or a return on investment? Again, I don't think we have a problem with investing in the state, but at the end of the day, as Representative Brixey pointed out, is these tax dollars, we just want to make sure that there's a return on that investment, right? So do you specifically have methods of tracking that success and being able to provide data to this committee on this is where the rubber meets the road?
So one of the things we do, and this is how we got that number, 51,000 prints, and these are all prints that are revenue generating, right? So we don't necessarily track what revenue was generating, but just the activity on that network is indicative of what's happening. The other thing that we look for is, and I'll go back to, what is Automation Alley? We are the Digital Transformation Insight Center for the state of Michigan. We see that manufacturing is changing culturally and foundationally as a discipline, it's changing. So what we're looking for is, what indications can we see that our manufacturers have actually changed and actually transformed? AJ's company is an excellent example. They're actually producing product that in a non-Project Diamond world would not have been competitive, because that product would have gone to China. They're actually able to change their technology, so they're actually able to source and produce that now in the state. So those are the types of indications we're looking at. We capture a lot of metrics from our manufacturers in terms of what prints they do, but we're also looking for those anecdotal stories of, you know, hey, what have you done that is transformative? Because the one thing that we've seen this time and again, manufacturers trust the stories of other manufacturers, not what we tell them. And so we're constantly trying to share those stories. And the nice thing is, in a peer group, there doesn't tend to be a lot of competition, because everybody's in their sort of their own community. So by building these communities, we are starting to see that crossover, you know, where AJ's company might learn from George's company and things like that. So absolutely, we capture those metrics, but there's nothing like 51,000 prints on the network since inception, because that to us tells the real story.
Great. I believe we have a question for Representative Bonak.
Yes, I want to thank you for your presentation. It's exciting. And what about the state of Michigan? What makes Michigan attractive for like startups and emerging technologies, and what might be some of the roadblocks in the state too?
Yeah. So obviously we live this life every day, like trying to make Michigan attractive especially. And I think the main thing that makes Michigan attractive, now I can only speak from the manufacturing perspective because we live that. We know how to make things. We know how to go from a concept to reality. And this is really important, because when I came out of school in the 80s and the 90s and the 2000s, it was all about software. Software is eating the world. And software will continue to eat the world. We're not going to slow that train down. But if you listen closely to the narrative that's happening globally, all of a sudden people are recognizing, oh my God, we got to know how to make things too, right? Militarily, of course, priority one. We need to know how to make things to protect ourselves as a country. But people are really starting to wake up to the fact that to be a great country, you have to make things. To be a great state, you have to make things. Well, guess what? 9% of the U.S.'s GDP is manufacturing. 20% of Michigan's GDP is manufacturing. We know how to make things. And we need to lean into that. It used to be that we couldn't get away from it fast enough. Remember, it was, how do we diversify out of manufacturing? It's going to kill us. My advice to all of you legislators is, that was the 90s and the 2000s. The world has changed. Pay close attention. People will begin to really value manufacturing again, and we need to lean in and say, now's our chance to shine. We know how to make things.
Great. One last question. One question. Representative Brixey, go ahead.
Thank you, Mr. Chair. So when you say 51,000 prints, does that mean like jobs amongst those network of 1,000? And
Right.
and the job would have like that little handle wasn't one of 51,000. The whole job was one. You said they needed 500 or 600.
So it's important to understand how 3D printing works. You might make one thing, or you might make something that is like an array of 50 things.
Right.
We don't know what that is. Every one of those is counted as a print. What we know is that that's what those printers are doing. Because we, again, just like what you said, we don't keep track of the intellectual property, what
Right.
was printed. But that's the answer. And we have 300 printers now on the network. And these are primarily those from phase 1, because phase 2 started. We've had now another 75 out on the field, but they just started going online. So we're talking about these original printers that were there.
So those little widgets,
Yeah. So if we
all 500 of those count as one of the 51,000. right?
potentially, yeah,
Right.
yeah.
So maybe
Yeah.
the way to describe it is, so this might be the print size of the 3D printer. You might have
Right.
10 of these, and that would be one print job.
Okay, so
So-
that order of 500 wasn't one print job. It was more than that,
Oh yeah, probably yeah.
of the 51,000. Okay, thanks.
Thank you all for your testimony. I think you've captured the attention of everybody on the committee, and you're doing something very, very unique. So we want to keep in touch with you and try to foster that success, and of course, keep our eyes open for those nuances and what those emerging technologies are and how AI is going to affect those. So again, thank you for your testimony today. Looking forward to staying in contact with you.
Thank you so much, Chair Mobley and the team. Thank you.
Thank you.
Thank you.
All right, seeing no further questions, Representative St. Germain moves to excuse all absent members. There being no objection, absent members are excused. There being no further business before the committee stands adjourned.